All right, well, welcome back, everyone. So we're going to start chapter 2. And chapter 2 is all about kind of algebra and dealing with matrices. So we're going to do things like add matrices, subtract matrices, multiply matrices. We're even going to learn kind of something like dividing by matrices. And to do that, we're just going to have to kind of get practice doing these operations. And so I'm starting this video with just a screenshot from our book, just to kind of show you the types of things we're going to be doing, right? And I'll go into them in more detail as we get there, but let's zoom in up here. So we've got a bunch of matrices. We've got A, B, C, D, and E. They're all different sizes, right? And so what we're being asked to do, let's just see, like this one is negative 2 times A. Well, we're going to have to figure out what it means if we multiply a number like negative 2 times a matrix. Or over here, we're doing A plus 2 times B. So we're going to have to figure out, well, what does it mean to do 2 times B? And then what does it mean to add it to A? And then we're also going to learn things like, what does it mean to multiply two matrices together? Can I multiply this matrix by this matrix? What would that mean? And, oh my gosh, if you look up in the instructions, if an expression is undefined, explain why. Oh my gosh, that means some of these things might not even be defined. We're going to talk about that, and we're going to learn what's going on there. Okay? And so the easiest place to start is to start with addition and scalar multiplication of matrices. Okay? And so we can add two matrices of the same size by adding their corresponding entries. And if two matrices have different sizes, then we can't add them. It's just not defined. If the matrices are different sizes, we can't add them. Or in other words, it's just undefined. Right? If I ask you what's 5 plus 6, you're going to say 11. If I say what's 5 plus a banana, well, there is no answer to that, right? It isn't a thing, right? We don't talk about adding numbers and fruits, right? And so in this class, the only thing we're ever going to add are matrices that are the same size. So if I had a matrix like 2, 3, 4, negative 1, and maybe let's make it have an extra column, and I want to add that to this matrix, I can do that. And I'm just going to add up all the entries. So I'm going to get 2, 4, 6, 2, negative 1, and 5. All right, I just took, for instance, this last entry, I did 3 plus 2, and I got 5. Okay? So adding is pretty reasonable. And if I had two matrices that were different sizes, like say I had something like this, the same first matrix, but I wanted to add to it, I don't know, a 2 by 2 matrix, something like this. This is undefined because it's like adding a banana and a race car, right? It's two completely different things. And so because these are of different sizes, this is a 2 by 3 matrix, and this is a 2 by 2 matrix. So the sizes aren't the same, so we're not able to add those matrices together. Okay? And so that's how we can add matrices. There are a bunch of properties that are going to be true when we add matrices. For instance, if I add a matrix A plus a matrix B, so that means A and B are the same size, that's going to be exactly the same as adding B plus A, right? And I want you to think about that, right? If I switch the order here of these two matrices up here, Well, at the end of the day, I'm going to add, if I switch these around, and maybe I can even do that. If I switch them around and added them in a different order, right? I hope you can see that nothing has changed, right? That we're still adding 2 and 3 to get 5. We're still adding -1 and 2, and -1 and 3 to get 2. The order of adding matrices doesn't matter, right? And so this is called the commutativity rule. So addition is what's called commutative. Okay? And we'll talk about commutativity in a little bit later today, and we'll see that it's not true when we multiply matrices. Right? So it is true when we add, and we're going to see matrix multiplication is a lot more complicated. Okay? So that's how we add matrices. Let's finish off this video by doing scalar multiplication. And then I'd like to keep these videos short. So how do we scalar multiply a matrix? So let's say we have a matrix A. Let's keep it as the same as before. Let's say we have a matrix like 2, 3, -1, 5, 3. And what if we want to do something like 4 times A? Well, that's just going to be multiply every entry by 4. Okay? So we're going to define scalar multiplication as just multiplying every entry by that scalar. So I hope I don't make any typos in these videos. But if I have, in general, if I do C times a matrix A is any size, C is a scalar, so it's a real number, then this is just multiply each entry of A by the number C. Okay. So again, I don't think this is such a surprising thing. I think if you had to guess what 4 times this matrix was, you would do that. You would multiply each thing. Okay. And so let's go back up to our exercises at the top of the page and see what ones we can answer. So I think we can look at these 4 parts here. Right? The other parts we're gonna deal with later. And so if I want to multiply the matrix A by -2, well, I could do that. I multiply everything by -2. So that would be okay. And now let's see, B minus 2A. Well, I guess I would compute first what -2A was. Right? And then I would add that to the vector B. Okay? So in this case, let's see if the matrices are the same size. Well, okay, so A is a 2 by 3 matrix. B is a 2 by 3 matrix. Very good. I could totally add those things together. And so if you want to see that worked out, B minus 2 times A, well, let's just write it out. 7, 1, 5 minus 4, 1 minus 3. That's B. Minus 2 times A, well, that's going to be 2, 4, 0, -5, -1, 2. And when I simplify that, I'm just going to do it all in one stroke. I'm going to do 7 minus 4, so that's 3. I'm going to do 5 minus 0, that's 5. I'm going to do 1 plus 2, that's 3. I'm going to do 1 minus 8, that's -7. And -4 minus -10, so that's -4 plus 10, that's 6. And -3 minus 4 is -7. Right? So one thing, there's no audience today because I'm making these videos alone to post for Saturday. If there's a small typo in these things, please just send me an email. I'll try to add that as a YouTube comment. But I may make a mistake. It's okay. So don't if I make a mistake, please just try to correct that. Okay. So very good. So that's that answer. The other ones are similar. A plus 2B. I'll leave that one to you. You'll have some on your homework next week for that. And now let's look down here. 3C minus E. Okay, well 3C, if we did that, that would be a 2 by 2 matrix. Right? 3 times C is going to be this matrix scaled up by a factor of 3. and that's going to be 2 by 2, and then E is a 2 by 1. Those are different sizes, and so this is going to be does not exist. Okay, so that's just undefined because the matrices are different sizes. Okay, so thank you for watching, and come back for the next video where we're going to